Welcome to AI Paper Podcasts. Today we're looking at a paper called OpenNovelty, an LLM-powered agentic system for verifiable scholarly novelty assessments.
And it tackles a huge problem. I mean, if you're an AI, you feel this. The sheer volume of new papers is overwhelming.
It's what people call the publication explosion. It puts this almost impossible burden on peer reviewers to accurately check if something is actually new.
And that's the core of what this paper from Fudan University, Wispaper.ai, and Claremont McKenna College is trying to solve with OpenNovelty. It's an agentic system designed for transparent, evidence-based novelty analysis.
The key thing to grasp, and this is really its main differentiator, is verifiability.
Right. It never, and this is critical, it never relies on the LLM's own memory, its parametric knowledge.
To avoid hallucinations.
Exactly. Instead, it does these contribution-level full-text comparisons against real papers it finds using a semantic search engine.
Every judgment it makes is grounded in, like, an actual quote or citation.
Yes. Explicit, verifiable evidence snippets. No trust, just verification.
And this isn't just a theoretical model. They actually deployed it on over 500 submissions for ICLR 2026.
Which shows it's a practical, scalable tool. The goal here is to make peer review fairer and, a lot more consistent.
So for this deep dive, that's our mission, to understand how they built this integrity firewall.
Okay, so let's really start with the scale of the problem. Why did novelty assessment need an agent like this in the first place?
Well, the pressure on reviewers is just unprecedented. You have tens of thousands of new papers hitting ArcGIS every year in just CS.ai and CS.lg alone.
It's impossible for a human to keep up.
It really is. Imagine you're a reviewer. You get assigned, say, 6 papers, and you have just a few days to confidently say that this new method hasn't been published before.
Yeah, and it could be buried somewhere obscure.
Right. Buried in a workshop preprint from 6 months ago. The scale is just too vast for the kind of fine-grained analysis that's needed.
And we've seen other AI tools try to help, but they have some pretty predictable flaws. Oh, yeah. If you just ask a standard LLM, hey, is this novel? It's notorious for just making up references, hallucinating.
Which is completely toxic for peer review.
It's the worst-case scenario.
Yeah.
And then you have the RG-based systems, retrieval-augmented generation. They're a bit better, but they usually just compare titles and abstracts.
Which misses the point.
It misses everything. The novelty is in the technical details, the specific loss function, the tiny architectural change. You need full text analysis.
So this is where OpenNovelty's 4-phase workflow comes in. It's their solution for creating that structure and verifiability.
Exactly. It starts with phase 1, information extraction.
Okay.
Then phase 2, paper retrieval. After that comes the real engine, phase 3, analysis and synthesis. And finally, phase 4, report generation.
All right, let's dive into phase 1, information extraction. They use a Claude model, and they make a point of saying it's in a zero-shot paradigm. Why is that specific choice so important?
It's all about avoiding bias. If you use few-shot, you give the model examples.
Right.
And those examples, even unintentionally, can spear the model. It might start preferring certain types of claims or certain writing styles.
So zero-shot is like asking it cold, with no hints.
Precisely. It makes the whole process easier to audit and ensures they're not just, finding what they told the model to look for.
And the extraction itself is very abstract. It's not pulling the catchy name of a model, but a short phrase like accelerating diffusion model inference.
Yes, and that is so vital for retrieval. That abstract, problem-focused language is way more likely to match how other researchers describe their work. It casts a much wider, more relevant net.
Okay, and besides that core task, it also extracts the specific claimed contributions.
Right, the new methods, the new architectures. But, and this is important, it explicitly excludes just experimental results. A better score on a benchmark isn't a novelty claim in itself.
It's about the how, not just the what.
Exactly. And all of this gets output as a structured object, which then feeds right into query generation.
And they don't just generate one query per claim, do they?
No, that would be too simple. They use a query expansion strategy. For each contribution, it generates one primary query and 2 semantic variants.
So you end up with something like 6 to 12 targeted search queries for every single paper.
Which gets us to phase 2, paper retrieval. This is where they use the Wispaper search engine with that broad recall strategy we talked about.
Meaning, again, they're trying to find absolutely everything that could be relevant.
Yep. The assumption is that a missed paper at this stage is a fatal error. You can't recover it later. So they start with a huge pool, often thousands of candidates.
But you can't analyze thousands of papers. That's where the filtering comes in, and this part seems pretty aggressive.
It is. The very first step is a quality flag filter. It only keeps papers that Wispaper's own verification system marks as perfect for semantic relevance.
And the paper says this one step can cut out 70 to 80% of the candidates.
It's a massive cut, a staggering number, really.
That feels risky. I mean, what if a genuinely refuting paper just happens to get a slightly less than perfect score from Wispaper? Isn't it just thrown out?
It is, and that is a calculated risk. It's a trade-off. They're prioritizing the quality of the pool that goes into the expensive analysis phase over capturing absolutely everything.
So they're betting that Wispaper's relevance score is good enough that any truly critical paper won't be missed.
That's the bet. They argued that if they let too much noise through, the LLM-driven taxonomy construction in phase 3 just gets degraded. So it's an aggressive but maybe necessary cleanup step.
Okay, so after that huge cut, they apply a top case selection.
Right. They take up to 50 papers for the general field context, the core task, and then up to 10 more focused candidates for each specific contribution claim.
And then some obvious filters, like removing self-references.
And the temporal filter, which is non-negotiable, it rigorously makes sure it only compares the paper against work that was published before it. A basic, but absolutely critical fairness constraint.
Okay, so we've gone from this massive ocean of literature down to a curated set of maybe 60 to 80 highly relevant papers. Now we're in phase 3, analysis and synthesis.
This is the core engine, and it starts by trying to make sense of that pile of papers by building a taxonomy.
A sort of family tree for the research area.
A great way to put it, it organizes those top 50 core task papers into a hierarchy, usually 3 to 5 levels deep. But the key is that it's LLM-driven, not traditional clustering.
And why is that better?
Because an LLM can generate human-readable, interpretable category names.
So instead of cluster 7, you get something like methodology, attention mechanism.
Exactly. It gives the human reviewer immediate, understandable context for where the paper fits.
And they enforce a strict rule here, the MECE principle.
Mutually exclusive, collectively exhaustive.
Break that down.
It's a way to force clean organization. Mutually exclusive means every paper fits into exactly one box, no overlap.
Yeah.
Collectively exhaustive means every single paper has a box to go into.
How do they enforce that?
With scope note and exclude note fields for every category. The LLM has to explicitly define what belongs and what doesn't. It prevents any ambiguity.
So once this map of the prior art is built, the real comparison starts.
Yep. First is the core task comparison. This just looks at the target paper against its immediate siblings in the taxonomy to give a high-level sense of how it's different.
But the real test, the heart of it, is the contribution level comparison.
This is where it gets really granular. The LLM takes each specific claim from the target paper and compares it against those 10 candidate papers we found. It then makes a 3-way judgment.
Which is?
Can refute, can not refute, or unclear.
Can refute is the big one. That means it found something.
It means it found prior work that seems to overlap. But this is where the system's integrity firewall really kicks in. Evidence verification.
The LLM can't just say it can refute a claim.
Absolutely not. It is forced to provide explicit verbatim quotes from both the target paper and the candidate paper that show the overlap. It has to show its work.
And even those quotes get checked.
They do. They use what's called a token-level anchor alignment algorithm to verify that those exact words actually exist in the source documents.
And if they don't, or if the confidence is too low,
then the crucial rule applies. Any can-refute judgment that lacks this verified evidence is automatically, no exceptions, downgraded to cannot refute.
Wow. So it's designed to be incredibly conservative. It would rather fail to make an accusation than make a false one.
That's the entire philosophy. Prioritize precision over recall when it comes to refutation. You cannot risk wrongly accusing an author of non-novelty with phantom evidence.
That's a fascinating design choice. It's building skepticism of its own output right into the system.
And that same verification engine is used for another task, textual similarity detection, which looks for potential plagiarism. But again, it's very careful. It just presents the evidence of high overlap and leaves the final judgment to the human.
So let's unpack the design philosophy here. These choices, like the zero-shot paradigm and the aggressive filtering, they reveal a lot about the creator's priorities.
They do. The zero-shot choice, as we said, avoids bias, but it's also just good engineering. It's much easier to maintain an audit than some complex, fine-tuned model.
And the broad recall strategy.
That comes from acknowledging that a missed paper early on is an irreversible error. So you overcapture at the start because you know you have robust filtering later on to clean it up.
But I think the most critical design choice was prioritizing semantic relevance. over things like citation counts or venue prestige.
Absolutely. This is a direct shot at a known systemic bias in academia. Citation metrics always disadvantage the newest, most relevant work.
Right. A paper published last month that completely refutes a claim might have 0 citations, but it's infinitely more important for novelty assessment than a famous paper from 5 years ago.
Exactly. The system is built for the speed of a field like AI.
Okay, now let's pivot to what's probably the most important section for our listeners.
Yeah.
The limitations. Where are this system's blind spots?
There are 3 really big ones, and they all come from the fact that it's reading text extracted from PDFs.
Which is notoriously messy.
Very. So the first limitation is a huge one. It cannot reliably handle claims that hinge on mathematical formulas.
So if your novelty is a new equation or a mathematical proof,
The system is essentially blind to it. The text extraction for equations and symbols is just too unstable. It can't parse them correctly.
wow, that's a massive blind spot for more theoretical papers. What's the second one?
Similar issue. Visual content is not analyzed. Figures, tables, architecture diagrams, pseudocode, all ignored.
So if your entire contribution is a new model architecture shown in a diagram,
Yeah.
OpenNovelty will only read the text around the diagram, not the diagram itself.
Precisely. For fields like computer vision or systems, that's a severe limitation that a user has to be aware of.
And the third limitation.
It's more of a philosophical one about retrieval boundaries. When the system says cannot refute, it doesn't mean no conflicting paper exists anywhere.
Right.
It means no conflicting paper was found within its search scope, so within the Wispaper index. You have to interpret cannot refute as no evidence found by the system, not as a definitive confirmation of novelty.
Which brings us back to the ethical framing of the tool. They're very clear this is an aid, not a replacement.
And it has to be. It provides evidence, but it can't assess methodological rigor or the significance of a contribution. Those are still uniquely human tasks. The final call always rests with the expert reviewer.
So to wrap this all up, OpenNovelty seems like a really significant step toward building structured, verifiable tools to help with one of the hardest parts of peer review.
It directly addresses that information overload that's stressing the whole research community.
And they're planning to push this even further with something called Novelty Bench.
Yeah, this is really exciting. To address that retrieval boundary problem, they plan to build a benchmark using data from human reviewers.
How would that work?
They'll take cases where a human reviewer cited a specific paper to challenge a novelty claim, and then use that as a ground truth to test how well different search engines, like Semantic Scholar versus Wispaper, are able to find that exact paper.
That would be a huge contribution to academic search in general.
Yeah.
It's about improving the whole ecosystem.
Exactly.
So let's end with a final thought for you, the listener. If a system like OpenNovelty becomes standard, what does that mean for authors? Does it create this new risk of people trying to game this system?
I mean, you could imagine someone using intentionally vague language or strategically leaving out connections to prior work, all just to make their paper harder for the retrieval agent to find.
So it becomes a cat and mouse game, authors optimizing their writing for AI clearance instead of for human clarity.
It definitely changes the incentives. It creates this new dynamic and arms race between the author trying to get past the agent and the agent trying to find the truth.
And how long until we need another AI agent whose only job is to detect that kind of gaming? Something to think about as these tools become a bigger part of our world.
That's the next frontier, for sure.
We really encourage you to go check out the OpenNovelty website. They've made all the reports from their analysis of those 500-plus ICLR 2026 submissions public. It's a fascinating data set to explore.